Hi, I'd like to welcome you to the Introduction to Linear Systems of Equations. The goal today is to teach you some of the terminology and give you a visual representation of some things we're going to be looking at. First, as far as the terminology goes, need to know a few things like what is a system of equations? System of equations is exactly a set of two or more equations. And wow, that just changed color. Don't know how I did that, but hey, a little fun anyway. Uh, So, a linear system then. There we go, linear system. Boy, things are sliding bad today. A linear system is a system of equations, i.e., once again, two or more equations, where we're using linear equations. Linear equations, of course, represent lines, and when we deal with these, in these cases, most of the time we're typically using two equations. Finally, a solution of a system is the set of values for the variables that work for all of the equations in the system. In other words, you're going to find values of x and y that make up a point that work for both lines in this case. The key is everything has to work for both equations, or if it's an overall system, it has to work for all of the equations. All right, most typical case for a set of linear equations is you will have two lines that happen to cross. The terminology for this is it is a consistent and independent system. What this means is it shares one common point in the two lines. Each line has one point in common, the point where they intersect. Second most probable case is you have parallel lines. In this case, the parallel lines do not share any points in common because they do not cross. This is said to be an inconsistent system. The point is there are no common points of the lines. Third case, and this is the one that's a little bit on the weird side, this is when they give you two equations for the same line. This system is said to be consistent and dependent. The two lines, since they overlap, share an infinite number of points. All the points on one line are also all the points on the other line, so they share an infinite number of common points. So, quick overview here. Consistent means that the lines have at least one point in common. Inconsistent, those would be the parallel lines. They have no points in common, no shared points. Independent means you only have one point in common, whereas dependent, there are an infinite number of common points. Running through a couple quick examples here. First one, with these two lines, the top equation has an intercept of 5. Slope is a -1. Since I am doing this on the smartboard and do not have straight edge, I'm going to put lots of points in there to try and help keep my lines fairly straight. As you can see, it works a little bit, not perfectly. Best bet is if you're doing this on your own, on paper, try using a straight edge. All right, second equation, we got the y equals 2x minus 4, meaning the y-intercept is at -4. Our slope is the 2, so we're going to go up 2 and over 1 for each point on the line. Or we can go down 2 and to the left 1. Once again, I'm doing lots of points to help try and keep my line straight. As we can see, this system would be consistent and independent as they cross in exactly one spot. All right, the solution set for this would be the point where they cross. The coordinates for that point would be 3 for the x and 2 for the y. Good thing you can do to double check these is to put the numbers back into the equations to see if they work. So in the top equation, if we put 2 in for the y, 3 for the x, if we double check it out, -3 plus 5 would equal 2. Check the bottom equation, we put the 2 in for the y again, 3 for the x, 2 times 3 would give us 6. If we subtract 4, we get 2 again. That equation checks. So that point is on both lines, and hence it's a solution to the system. In this case, top equation has a y-intercept of 3, slope of -1. Once again, I'm going to do lots of points, hopefully trying to get straight lines. Not real good in this case. Hope you guys can use your imagination, make it look straight. Second equation starting at -2. Once again, the slope is -1. Although not perfectly drawn, hopefully you should be able to get the idea that the two lines are parallel. They will not cross, and hence there is no solution. This is an inconsistent system. We'll not be able to find any points in common in the two lines. As a quick reminder, the way you know two lines are parallel is you look at the slopes, the coefficients in front of the x in the equation. In this case, both of them are -1. Same slopes, different y-intercepts, hence the lines are parallel. All right, last example. A lot of times when they do this, to come up with two ways to write the same equation of a line, they're going to vary the form. Top form is in standard form. Quick review, one way to graph these is to use the intercept method. So if x is 0, we know that -2y would equal 10. Divide by -2, we would get y equals -5. So it means we have a point, add 0, and -5. When we set y equal to 0 for the top equation, that leaves us 5x equals 10. We divide by 5 then. X is 2, meaning that point would be at 2 and 0. If I draw the line through those 2 points, once again, not real straight. Hopefully you guys can draw straighter lines than I can. We get that line. If we check out the second equation, which is in slope-intercept form, we see the y-intercept is at -5, which is exactly where we put it, and the slope is 5/2, 5 over 2. So if we go up 5 over 2, we find out we end up with the same 2 points we just had when we were graphing it out of standard form. Now it's looking a little straighter. But as we can see that the two lines are overlapping. This would be a consistent and dependent case because every point on the one line is also on the other line. Finally, last thing. Soon we will be trying to solve these equations algebraically, so some things to look for. When we do things, a system that is consistent and independent, we will find a solution for both x and y. So for an example, we may find out x is 2 and y is 5, meaning the point that the two lines would cross at would be at 2, 5. A consistent and independent case, you'll come up with one answer for x, one answer for y. In the consistent and dependent case, all the variables will cancel out and you will end up with a true statement. For an example, you'll get 0 equals 0. You could get 2 equals 2. You can get anything where it is a true statement. That is telling you you've been given two different equations for the same line. All the variables cancel out and you end up with a true statement. Last type is the inconsistent system. These are the parallel lines. You end up with a false statement in this case. For an example here, you may end up with 0 equals 2. You could end up with 5 equaling 17. It doesn't matter. Whatever statement you end up with will be false. All the variables will cancel out, but basically because the intercepts are different, you'll end up with a false statement at this point. Hope this has provided you a brief overview and helped clear up any problems you may have been having. Have a good day. Bye.